Okay, so I'm going to go over how to do the line of best fit or finding the line best fit of best fit in some scatter plot data. So the first one we're going to look at is this one here. We can see that we have a positive association and a positive form because all of our data seems to be going upward. We have one outlier maybe here that we wouldn't consider to be part of the data set. So the first thing I'm going to do is I'm just going to take my line, and remember, you're not playing dot to dot. What you're trying to do is find a line that satisfies kind of an equilibrium between both all the sets of data. So you're not actually trying to connect dots. You're just trying to find a line that would represent all of the data. So that's your first. That's your first step. That is to split the data, and so that's what we're doing. And then you're going to find the slope between any 2 points on the line. So you can either use, we haven't learned slope formula, so what we're going to do is use growth triangle. So we're going to look at our line where it intersects in certain places, like we have an intersection here, and we have an intersection here. So we can make that a growth triangle. So remember, this is our change in y, or x, my bad. And this is our change in y. So when I look here, well, I went 1 unit across, and then I went 1 unit up. So my slope, so my change in y equals 1, I went up 1 unit, divided by my change in x, which also equals 1 unit, so my slope equals 1. Okay? Now we have to, the other part is to find the y-intercept. So remember, the y-intercept is where this line starts on our graph, and that's actual point of 0, 2. So we use the y out of that. This is the x, this is the y. And then we put that into our slope-intercept form, or our linear pattern, which we called it, y equals mx plus b. So the m we have always referred to as growth, but it's actually our slope. That's the word that we will use, or the term that we will use for the remainder of the year. And the b, remember, is our y-intercept. Okay, so now I have my slope, I have my b, so I can write an equation for my line of best fit as y equals, well, my slope was 1, so I'm just going to use x plus, and it starts at 2. So the line of best fit equation is x plus y equals x plus 2. Okay? So this is a positive association with a positive linear form. This one is more of a negative association. And so we're going to split our data by drawing in a line. To kind of split that data. So we have came close to a point here. We have probably a little more data on this side of the line than this, but it's pretty fair. So then again, we're going to we want to find our slope first. So we're going to look for points of intersection where this line actually hits actual points on this line, which it's kind of hard to tell on here, but we're going to say this one. And this one might be a little harder. We'll go with this one. Well, no, not that one. I think I might have to change. I might change the pitch of my line just a tiny bit, just so I have some points of intersection. Just for the sake, it doesn't always work out like that, but just for the sake of. So here's one here, and here's one here. I'm going to draw in my growth triangle. I might use a different colored pen. So here's my growth triangle. So I'm looking at the point here to here. Okay? So now I see that my change in x is 2, and my change in y is also 2. But I went down 2, because this is going down 2 and then over 2. So that's the difference between this one and this one. And then the other thing I need to figure out is my y-intercept, which is here. So this is 07, or 07 is that point. So now I'm ready to write my line of best fit equation. So that was y equals, well, I had a change in y of -2 and a change in x of 2. So -2 divided by 2 is -1. So I'm going to have a negative, and I can either put a 1 in there, or you can just call it -x plus 7. Either form is correct. So this is the line of best fit equation for this graph. Now the last graph we're going to look at is a graph with no association. And so when they have no association, we do not have a line of best fit. It's because if I try to split this data, which it's accurate for this line of data, but then we miss all the other line of data. So we don't actually have a line of best fit when we have no association or a nonlinear form. Okay, and so then when we look at the example problem on the next slide, you're given 4 different lines. I have graphed it in Desmos for you, and they want you to look at some equations, which is y equals 2/3 x plus 50 is 1. That's your purple line. And then you had y equals 3/2 x plus 50, which is a black line. Then y equals 2/3 x plus 55, which was, I think, a green. Oh, wait. This one is black, my bad. And this one is green. And then y equals 3/2 x plus 55, which is the red line. So the thing that we probably haven't practiced the most with is even just how to graph these lines. And so if I were going to graph these lines, well, I know this is my y-intercept. So this is where my line begins. So this one begins at 50. And I need to go up 2 and over 3. So I'm going to go up 2 units, so not very much, and over 3. And so I do that each time. So then I get these lines. So I get a line like that. Now if I were going to do, I don't have a green in here. So then for my next line, which is green, I'm still going to start at the same place, but it tells me I'm going to go up 3 units and over 2. So that line is going to look a little bit steeper. So it's going to look more like that. And then my next line, I'm going to start at 55, so it's going to start right here. I'm going to go up again, up 2 and over 3. So really shallow pitch. So that's what that line looks like. And then my last line, again, I'm starting here. And then I'm going up 3 over 2. So again, that has a steeper pitch. So it looks more like that. And so then they want you to, and we have to remember this line is actually purple, not red. So we want to look at each of these lines and which one looks best with our data, which one divided it the most equally. And I would say, looking at this the way I have it drawn, I would probably venture and say that the green one, the 3/2 x plus 50, is probably the better match according to this data. I can't remember what it looked like in the Desmos, but it might be different in the Desmos just because my scaling and my graphing is just a tiny bit different. But really what I wanted you to remember as far as making those decisions or graphing lines is that this is our slope. So this is your y and this is your x. So you would go up 2 over 3 or up 3 over 2.